Hi guys, welcome back to my mathematics tutorial. My name is Peter C. Dokpo Jr., your math tutor, and I am also an instructor of mathematics at the University of Liberia. So in today's lesson, we want to continue with finding derivatives of trigonometric function. So in previous lesson, we solved up to 6 different examples. So we want to solve more examples so that at least we have more understanding on how to find the derivative of a trigonometric function. So question number 7 says y equals to 2, the square root of tangent of x. So one way we can think of solving this problem is to just get rid of the square root and use implicit differentiation. So to get rid of this square root means that we must square both sides of the equation. So y squared now will be, this is 2 squared and the square root of tangent of x all square. So this will cancel. So we have y squared to be equal to 4 tangent of x. Now we can find the derivative of y squared equals to 4 tangent of x. So y squared is 2y, then we attach y prime because it's the name of the function, and then equals, we hold the 4, we differentiate secant, we get, let's say we differentiate tangent, we get secant square x. Now we can just simplify. Now let's just simplify the problem. So remember, you must solve for y prime. So we divide both sides by 2y. So 2y cancel 2y. Y prime now equals this 2 cancel 2 from here. So we'll be left with 2 secant square x all over y. But we need to bring in the value of y. Initially we had y to be equal to this expression. So we must bring in the value of y. So we have y prime now to be equal to 2 secant square x all over this y now is 2, the root of tangent of x. So 2 cancel 2. We have y prime to be, now we can rationalize this tangent of x, because we just want to get rid of the square root from within the denominator. So this is secant square x, tangent of x. Then this tangent of x, the root of tangent of x times the root of tangent of x. When we multiply in two like roots, we take one of the radicands, because the root will just cancel it, because it's like saying half plus half is equals to 1. Now, secant square x and then tangent of x, we can simplify that. So y prime equals, so this secant square x is 1 all over cos of x, and then tangent of x divided by this tangent of x, which is sine of x over cos of x. So division of fraction says we must reciprocate the second fraction. This is the second fraction. So y prime equal to the square root of tangent of x all over cos of x. Now this secant is square. So this now gives us cos of x all over sine of x. So what happens? Cos of x will cancel 1 from here. You left with cos of x. And what will we be left with? We will be left with y prime equals square root of tangent of x all over. Now, cos of x and sine of x is the same as sine of x times cos of x. But what do we know? We know that sine of 2x is equal to 2 sine of x cos of x, which is the double angle identity for sine. So if we divide both sides by 2 so that we'll be able to solve for the sine of x and cos of x, we will just have sine of 2x, 1 over 2 sine of 2x is equal to sine of x cos of x. So what happens? We can now say y prime equals So the square root of tangent of x all over this now is just sine of 2x. Now all over 2. So this 2 can come in this numerator. Then finally, because we still have to simplify the problem. Finally, we have y prime to be, now this is 2. Now we know that 1 all over sine of 2x, then tangent of x. So we know that 1 all over sine of x is just equals to cosecant of x. So whatever the angle that is here, it's the same angle that will be on this side. So the fact that this is 1 over sine of 2x, it means you will have cosecant of 2x, then the square root of tangent of x. This is y prime. So this is why I told you that you must master the trigonometric identities, especially when you are dealing with derivatives of trigonometric functions. You must master the trigonometric identities because you will always use them in your problem. So thanks also much for watching. See you in our next video.